All right, let's jump right in. Today, we're digging into what it actually takes to be a civil engineer in this day and age. We're going to cover everything from the bedrock principles that built our world to the seriously high-tech tools that are creating the future. Let's get to it. You know, that's a pretty bold statement, but it's absolutely true. I mean, think about it. The road you drove on this morning, the office you're sitting in, the bridge you cross every day, a civil engineer had a hand in all of it. It's one of the oldest and frankly most important jobs out there.
So what's changed? Well, it's not like they're still using slide rules and giant drafting tables anymore. The modern civil engineer's toolkit is digital, it's powerful, and it's totally essential to getting anything done. So what exactly is in that toolkit? Let's find out. Okay, first things first. Before we get into the gear, let's lay a solid foundation and talk about what this whole discipline is really about. And that covers a ton of ground. We're talking roads, massive bridges, dams that hold back entire lakes, airports, and of course, the buildings that make up our cities. At the end of the day, the goal is always the same: create solutions that are safe, efficient, and make our lives better. You might think civil engineer is just one job, but it's actually a huge field with a bunch of different specialties. And to be a great engineer, you really need to understand these core pillars. Look at this. The field is incredibly diverse, right? You've got all these different interconnected areas. Each one plays a super specific role, so let's just quickly run through a few of the big ones. So, structural engineers, yeah, they're the people we thank for our buildings and bridges not falling down. Seriously, they're doing all the complex math to figure out how things will stand up to wind, earthquakes, and even just the weight of all of us inside. Now, before you can build up, you gotta understand what's down below. You can't just stick a skyscraper anywhere, right? Geotechnical engineers are the ones who analyze the dirt and rock to make sure the ground can actually support whatever massive thing we're about to build on it. And how do we all get around? Well, that's where transportation engineers come in. They design the highways, the train systems, you name it, always trying to make traffic feel better and keep us all safe on the move. And it doesn't stop there. You've also got environmental engineers, water resources engineers, and construction managers who actually bring the blueprints to life. Every single one of these specialties is absolutely vital for a modern project to succeed. So we know what they do, but how do they actually take an idea and turn it into, a real thing? Well, it all follows a very clear, step-by-step blueprint. And this is that blueprint. Every project pretty much follows this path. You start by figuring out what the actual problem is. Then you go out and collect all the data you could possibly need. You analyze that data to find the best way forward, which leads you to the super detailed design phase. After that, it gets built, and finally, it's maintained to make sure it lasts. Okay, now we get to the really good stuff. To actually go through that whole process today, engineers rely on a powerful digital toolkit. Forget the old drafting board. The modern workstation is where all the magic happens. I absolutely love this quote because it's so true. Your laptop isn't just for checking email. It is the primary weapon for design, for modeling, for all the heavy calculations. It's what you bring into battle to solve these incredibly complex problems. And the software they're running, man, it's heavy-duty stuff. Programs like AutoCAD, Revit, and Civil 3D are the industry standard for a reason. They all work together. But to run these things, you need some serious horsepower. They will bring a weak computer to its knees. Just look at the gap here between minimum and optimal. It's huge. Sure, a machine with 16 gigs of RAM might run the software. But if you want to be efficient, if you want to handle a huge 3D model without waiting 5 minutes for it to respond, you have to aim for optimal. More CPU cores let you run complex simulations. More RAM means you can have multiple huge files open at once. And a powerful GPU isn't just for video games. It's what lets you smoothly spin that massive 3D model around on your screen. That's the difference between just getting by and actually being productive. So, you know you need a powerful machine. How on earth do you pick the right one for you? Let's break down a few recommendations for different people. For all you students out there, listen up. You don't have to sell a kidney to get a decent laptop. The Acer Nitro 5 or the Asus TUF series are awesome choices. People call them budget beasts because they pack a serious punch with good processors and graphics cards, but at a price you can actually afford. Now, if you're out in the professional world, you're probably going to want to step things up a bit. The HP Victus or Omen laptops or the Lenovo Legion 5 are fantastic. They handle heavy-duty rendering and multitasking like a champ, and they look a bit more professional too. Just great all-around machines. And then you have the top tier, the big guns. We're talking about the Dell XPS 15 or a MacBook Pro. These things combine insane performance and beautiful screens with a really premium design. If you need the absolute best or you want something that looks slick in a client meeting, this is where you look.
But wait, before you rush out and buy something, remember that specs aren't the whole story. A laptop that runs hot is going to slow down, so good cooling is a must. If you're ever on a job site, good battery life is a lifesaver. And trust me, having a nice, sharp screen and plenty of ports makes your day-to-day life so much easier.
And let's end with a little dose of reality here. Anyone who's worked in this field knows this feeling all too well. You can have the fastest computer on the planet, but the pressure is always on. This is exactly why having a fast, reliable machine isn't a luxury, it's a necessity just to keep up. So, at the end of the day, all these tools, from your fundamental knowledge to your high-performance laptop, they're all serving a bigger purpose. They're what allow engineers to design and build the world we live in. So the real question isn't just about what's in the toolkit. It's about what amazing things you're going to build with it.